In the vast expanse of the cosmos, celestial phenomena have captivated and frightened humanity for millennia. On a warm summer's day in August of 2017, an extraordinary celestial event unfolded across North America. In a rare occurrence, a total solar eclipse crossed the land exclusively in the United States, an event so unique it earned the name the Great American Eclipse. People gathered in cities, towns, and open fields across the country to find the perfect spot to witness this once-in-a-lifetime spectacle. As the moon began its occluding dance in front of the sun, crowds looked on in awe. Shadows sharpened and became crisply defined. Disoriented animals ran, stopped in confusion, and bolted off in panic. The entire horizon in every direction appeared to be a sunset. The sky fell so dark that Regulus, the 21st brightest star in the night sky, became visible. But as darkness traced its way across the land, a peculiar mystery emerged. 7 cities along the path of totality shared a name: Salem. The significance of this occurrence captured the imagination of those steeped in biblical prophecy. Salem, the anglicized form of the Hebrew word shalom, is short for Jerusalem and means peace. Was this a cryptic message encoded in the cosmos? Could the darkening of these cities signify that peace will be taken from the land? Could it point to future end-time events or places? Was the Great American Eclipse a mere astronomical coincidence? Or a deliberate biblical sign of the end times inscribed in the heavens? Join us on this episode as we dig deep into the mystery to uncover what this eclipse actually means. We are living in unprecedented times. Biblical prophecies, words shut and books sealed for millennia, are being opened and interpreted. Prophecy, both ancient and modern, is being fulfilled. We have passed a hinge point in the history of the world. I wake up and find myself identifying with Dorothy of the Wizard of Oz.
Toto? I have a feeling we're not in Kansas anymore.
I speak with a certain sense of concern and urgency, and not without a healthy measure of trepidation, when I say we are witnessing the unfolding of momentous events marked by signs of importance in the heavens and on the earth. Rampant deception of the type that Jeremiah warned of undergirds our society. The incoherency of world leaders is staggering. Isaiah saw our day and remarked, "The princes of Noph are deceived, and the princes of Zoan are become fools." Historical and astronomical events, side by side with prophecies from Daniel, Isaiah, John the Revelator, Jesus Christ himself, and others, are coalescing into a map-like tapestry, showing us when and where we are on the prophetic timeline. Numerous people have conjectured and spoken about the August 21st, 2017, and the April 8th, 2024 eclipses, and the X, the passive totality of these two eclipses, scribe out across America. But few, if any, have noticed a third companion eclipse that completes the triad. This eclipse occurred on December 14th, 2020, precisely 1,211 days after the 2017 eclipse, and precisely 1,211 days before the 2024 eclipse. I have dubbed this event the missing eclipse. The X does mark the spot. However, this eclipse marks the time. When you understand what this triad truly points to, Those with eyes that see and ears that hear will know that we're not in Kansas anymore.
No, I know we're not in Kansas.
The Great American Eclipse captivated millions as it traversed the United States from coast to coast. But why America? What role does this nation play in the grand tapestry of God's divine plan? The answer lies in the concept of the land of Joseph, Joseph who was sold into Egypt, and in the New Jerusalem. In this and subsequent videos, we will put the prophetic puzzle pieces together one by one. Stick with us and you'll see a future vision emerge that is both great and dreadful. But let's not get ahead of ourselves. First, we need to break down and examine the pieces to fully understand what this all means. First, we'll take an in-depth look at what an eclipse is and the conditions necessary to produce one. Then, we'll examine the three primary differentiating characteristics between eclipses and discuss what would or wouldn't support the assertion that an eclipse can be a sign in the heavens. Then I'll walk you through my boots on the ground Great American Eclipse experience. I'll highlight a unique discovery I made regarding this eclipse that I put on the shelf because I only understood the significance of how it relates to America and biblical prophecy 3.5 years later. Everyone wants to know, when is the second coming? But if we search for the answer to that question without understanding what is the second coming, we will likely misinterpret signs and scripture and become confused. Finally, we'll summarize what we can take away from this episode. By understanding with specificity what a total solar eclipse is and the conditions necessary to produce one, we gain the insights to appreciate the uniqueness of our planet, its sun, the moon, and our solar system. The fact that we can have a perfect total solar eclipse on our Earth is an improbable occurrence in the cosmos. An eclipse is a celestial event that occurs when one astronomical object, such as the moon or a planet, moves into the shadow of another astronomical object, or when an object passes directly in front of another, partially or completely blocking its light. The most well-known and observed types of eclipses are solar eclipses and lunar eclipses. A lunar eclipse occurs when the Earth moves between the sun and the moon, casting a shadow on the moon. There are three types of lunar eclipses: total, partial, and penumbral. In a total lunar eclipse, the moon passes through the Earth's innermost shadow, the umbra, resulting in a reddish hue due to the Earth's atmosphere bending some sunlight onto the moon. Only a portion of the moon enters the umbra during a partial lunar eclipse. In contrast, in a penumbral lunar eclipse, the moon passes through the Earth's shadow, known as the penumbra, appearing slightly darker. Lunar eclipses are very common. On average, we have about 3 of them each year. There has been a lot of talk of this reddening of the moon as being the manifestation of the biblical reference of the moon turning to blood. I'm not at all convinced. At any rate, we won't be spending time in this video series on lunar eclipses. Let me know in the comments if you think I'm missing something by not examining them. Please be thoughtful and respectful and try to make a compelling case. A solar eclipse happens when the moon moves between the Earth and the sun, obscuring part or all of the sun from an observer's perspective on the Earth. There are 4 types of solar eclipses: total, partial, annular, and the rarest type, a hybrid eclipse. In a total solar eclipse, the moon fully covers the sun, creating a short period of darkness known as totality. During a partial solar eclipse, the moon partially covers the sun, leaving a crescent-like shape visible. An annular solar eclipse occurs when the moon is at its furthest distance from the Earth and doesn't fully cover the sun, resulting in a ring of light around the moon. This type of eclipse is known as a ring of fire eclipse, due to the annular ring of the sun not being obscured by the moon. A hybrid eclipse occurs when the moon transitions through its critical distance from the Earth. If it moves further away, the eclipse will become an annular eclipse. If it moves closer, it will become a total eclipse, hence the name hybrid. On October 14, 2023, an annular eclipse crosses North, Central, and South America. Notionally, this eclipse is interesting because it might have some significance. I haven't made any connections yet, and perhaps there are none, but this is one I'm definitely interested in. If you have made any connections, please tell us in the comments, and again, please be respectful. Genesis chapter 1, verses 14 through 18. And God said, "Let there be lights in the firmament of the heaven to divide the day from the night, and let them be for signs, and for seasons, and for days and years." In episode 1, I review verse 14 extensively. An incredible amount of meaning is packed into the Hebrew of this verse. In this episode, we'll emphasize the phrase, "Let them be for signs and for appointed times." Verse 15, "And let them be for lights in the firmament of the heaven to give light upon the earth, and it was so. And God made two great lights, the greater light to rule the day, and the lesser light to rule the night. He made the stars also." The perspective of verse 16 is so interesting. The narrator sets the two great lights side by side, just as in this picture. Both of them are great, but the greater is much brighter. The lesser, still great, however, isn't as bright. The verse jumps off the page from the perspective of equal apparent size of the sun and the moon. I'm going to use verses 14 and 16 to synthesize a verse, my own verse. Try this one on for size. "And God made two great lights, and he made them for signs and for appointed times." It seems you either have to accept that we as humans are the beneficiaries of numerous incredible coincidences and improbable fortunes, or intelligences skilled in cosmic engineering organize the elements with intention and purpose. Verse 17, "And God set them in the firmament of the heaven to give light upon the earth, and to rule over the day and over the night, and to divide the light from the darkness. And God saw that it was good." The sun plays an obvious critical role in creating the conditions necessary for life on Earth. Our sun is the solar system's largest and most massive object. If it were a hollow shell, it could fit all 8 planets inside nearly 600 times. It contains 99.8% of all the mass in the solar system. Because of this mass, the sun has a tremendous pull on the fabric of space. This gravitational pull allows the sun to hold together a system of 8 planets, potentially dozens of dwarf planets, over 170 moons, and countless comets and asteroids. Without the sun's gravity, these celestial bodies would drift off into deep space. 91% of its atoms are hydrogen, 8.9% are helium, and 0.1% are heavier elements. The sun is an enormous fusion reactor that converts this hydrogen into helium, releasing the light and energy for the entire solar system. Another critical property of the sun is its magnetic field, which encapsulates the entire heliosphere of our solar system. This force field created by the sun's plasma pushing electrically charged particles towards the star's poles protects the planets from harmful cosmic radiation. If the sun were much larger, it would burn through its nuclear fuel more rapidly and have a much shorter lifespan. The shorter lifespan wouldn't allow enough time for the conditions on Earth that support life to develop as they have. If the sun were much smaller, it would be more unpredictable. Smaller stars are known for their violent flares and intense radiation, which could strip away a planet's atmosphere and bombard its surface with harmful radiation, making it less hospitable for life as we know it. Additionally, a smaller star's habitable zone, the region where an orbiting planet could have liquid water on its surface, would be much closer to the star, which could lead to other problems like tidal locking. So the sun is indeed in sort of a Goldilocks zone of star sizes. Not too big, not too small, but just right for supporting life on Earth. This is not to say that life couldn't exist in systems with larger or smaller stars, but the conditions would be much less probable. With its formidable magnetic field, the sun serves as a protective shield for our solar system, warding off harmful cosmic radiation. Its immense gravitational pull acts as an invisible tether, keeping the planets, moons, and countless celestial bodies in check, preserving them from spiraling into the vast expanse of space. Moreover, the sun's capacity to generate staggering amounts of energy breathes life into our solar system, fostering the conditions necessary for life as we know it. The role the moon plays is less obvious and perhaps even lesser understood, but it is paramount in fostering life on our planet. Its effects on the Earth are so important in sustaining life. Its effects on the Earth are so important in sustaining life that we either got very lucky with our cosmic slot machine or something more deliberate is going on. The moon's gravitational influence stabilizes the Earth's axial tilt, ensuring consistent climates and predictable seasons essential for habitable conditions. Without this anchor in the sky, the Earth's tilt could vary dramatically, leading to severe swings in climate Without this anchor in the sky, the Earth's tilt could, oh my goodness, Rob, pay attention. Without this anchor in the sky, the Earth's tilt could vary dramatically, leading to severe swings in climate and Without this anchor in the sky, the Earth's tilt could vary dramatically, leading to severe swings in climate at different times and locations depending on the axial tilt. As the Earth rotates, the moon's gravitational force generates tides, shaping coastlines and nurturing diverse marine ecosystems by distributing nutrients. The interaction between the Earth and the moon has gradually slowed the Earth's rotation. This has increased the length of days and nights over billions of years. This slower rotation reduces the velocity of surface winds and extreme weather. This same interaction has also helped sped up the moon, moving it further from the Earth. Billions of years ago, the moon was much closer to the Earth. The tides from this much closer moon would have been massive, with shorelines moving back and forth hundreds of miles daily. This water flow sculpted the Earth's surface, especially in the coastal regions. With the moon at its current distance, tidal flows are highly supportive of life. Acting as a guardian, the moon attracts and captures potential impactors, reducing the risk of catastrophic events on Earth's surface. Furthermore, the moon reflects sunlight to Earth, enhancing nighttime illumination, facilitating nocturnal activities and aiding navigation. The night would be almost totally dark without the moon. The very impact of the Mars-sized planet that formed the moon 4.5 billion years ago also transferred the heavier iron from this planet to the core of the Earth, giving the Earth an unusually large iron core. The moon's gravitational force acts on this core, much like it acts on the oceans in a process called tidal churning. It churns the molten liquid in Earth's core, causing current in the form of electricity, thus creating Earth's magnetic field, which plays a vital role in protecting life on our planet. This magnetic field, acting as a shield, deflects the harmful solar wind and radiation from the sun, safeguarding our atmosphere and surface. This protective force helps preserve the ozone layer, shielding us from harmful ultraviolet radiation. Additionally, the magnetic field acts as a guardian against solar flares, absorbing high-energy particles and preventing their direct impact on Earth. The magnetic field also maintains our atmosphere, preventing its erosion and ensuring the necessary atmospheric pressure for life. Furthermore, it helps preserve water on Earth's surface, fostering the existence of liquid water, a crucial ingredient for life as we know it. Beyond protection, Earth's magnetic field aids in navigation and orientation. It is a reliable reference for compasses. enables migratory animals to navigate their long-distance journeys, and assists birds, bees, and marine species in finding their way. These benefits make Earth's magnetic field an essential component in the delicate balance that allows life to thrive on our planet. It seems that we hit the jackpot in the cosmic lottery with the moon. The Earth has a diameter of 7,926 miles, about 4 times that of the moon, which has a diameter of 2,160 miles. From a volumetric standpoint, the Earth occupies nearly 50 times the space occupied by the moon. But from a mass standpoint, the Earth is just over 81 times more massive than the moon. The Earth is significantly denser than the moon, thanks to its large iron core. The moon's size is relatively large compared to the size of the Earth when considering the size of the moons orbiting other planets. So large that many scientists consider the Earth and moon as a local two-planet system. Earth's moon ranks as the 5th largest among the more than 170 moons in the solar system. It is surpassed in size only by 3 of Jupiter's moons, Ganymede, Callisto, and Io, and 1 of Saturn's, Titan. It is truly remarkable and improbable for the moon to be so large compared to the Earth. The precise circumstances that led to the formation of such a relatively large moon for a planet the size of Earth remain a subject of scientific investigation. When I think about an eclipse diagram, I think of the sun on the left and the Earth on the right, with the moon in between. So let's swap the positions of the Earth and the moon. Ultimately, we're working towards getting to an eclipse diagram. Hopefully, we will carry with us insights into the sizes, distances, and notionally, how improbable it is that all these things line up so precisely. The average distance between the moon and the Earth is about 239,000 miles. The moon follows an elliptical path around the Earth with an eccentricity of about 0.055. What does that mean? It means there's a 14% difference between the furthest and closest points in the moon's orbit to the Earth. The moon at apogee, the furthest it gets from the Earth, is 252,700 miles. At perigee, the closest it approaches the Earth is 221,500 miles. Let's go ahead and view their sizes and the distance between them with the correct proportions. Here the relative sizes are correct, but now we will scale them so that the distance between them is also in the proper proportions. So there you go. Those are the correct proportions. If you were to come flying back from Mars in an Elon Musk spaceship, you decided you didn't want to colonize Mars after all. You'd rather just be back on Earth. This is what it would look like as you approach the Earth and Moon. Of course, there would be a zillion stars and galaxies in the background, and depending on the time and your approach path, you might also see a few planets. The Earth is large relative to the size of us humans, but comparatively, the Moon is a long way away. The Earth orbits the Sun in a well-defined plane known as the Earth's orbital plane. Conversely, the Moon orbits the Earth in its own orbital plane, which is tilted with an inclination of about 5 degrees compared to Earth's orbital plane. Understanding these orbital planes and how they interact is vital to comprehend the dynamics of eclipses. Notice the graticule around the Moon. The yellow lines indicate the furthest above and the furthest below the Earth's orbital plane that the Moon travels. When the Moon is in the pink box, it indicates that the Moon is in a zone close enough to the Earth's orbital plane to cast a shadow on the Earth. When it is above or below the pink box, the shadow cast by the Moon will either be above or below the Earth. As the Moon orbits the Earth, it is constantly moving above and below the Earth's orbital plane. It takes the Moon 27.3 days to make one 360-degree orbit around the Earth. This is known as the lunar sidereal orbit period. Each time the Moon makes one complete orbit, it passes through this pink zone exactly twice. The Moon crosses this zone 26.75 times each year. However, by the time the Moon has completed this 360-degree orbit, the Earth has traveled nearly 27 degrees in its orbit around the Sun. It takes 2.2 additional days for the moon to orbit far enough to account for the trajectory of the Earth. The moon takes just over 29 and a half days to make one complete orbit relative to the sun as viewed from Earth. This is known as the lunar synodic orbit period. During this time, the moon travels slightly more than 389 degrees around the Earth. From full moon to full moon, new moon to new moon, or one trip around the ecliptic, it takes 29 and a half days. The moon passes between the sun and the Earth 12 and 1/3 times yearly. A solar eclipse happens when the moon is in the zone close enough to the Earth's orbital plane and is also passing between the sun and the Earth. A total solar eclipse happens on average about once every 18 months. On a tangential note, with the new moon to new moon taking 29 and a half days, a month in a lunar-based calendar will have either 29 or 30 days, no more, no less. This fact will be important to understand when we start talking about the feasts of the Lord as outlined in Leviticus chapter 23. Understanding the feasts of the Lord is paramount in decoding biblical prophecy. The degree of inclination of the moon's orbital plane relative to the Earth's orbital plane considerably influences the frequency of eclipses. For instance, if the Earth and the moon's orbital planes were coplanar, we would have a total solar eclipse and a total lunar eclipse every single month, at every full moon and every new moon. Let's take a look at the relative size between the Earth and the Sun. The Sun is enormous compared to the Earth. The Sun has a diameter of 864,000 miles, 109 times larger than the Earth's, which is 7,926 miles. From a volumetric standpoint, the Sun occupies 1.3 million times the space occupied by the Earth. From a mass standpoint, the Sun is about 333,000 times more massive than the Earth. However, the Earth is almost 4 times denser than the Sun. This difference in density is due to the Sun consisting primarily of hydrogen and helium held together by its own gravity. It is a massive fusion reactor that fuses hydrogen to form helium with a very dense core, but gets much less dense closer to the surface. I wanted to make an accurate size distance graphic, but you can see that the size of the Earth in this video clip is only a few pixels across. If we shrunk down the Earth's and Sun's sizes to show the distance between them relative to their sizes, the Earth would be less than 1/100th of a pixel across. The sizes and distances in space are so vast that it's challenging to show them visually. Let's examine the apparent and relative size of the moon and the sun. This is a highly significant relationship, a relationship that is very curious and very improbable. The diameter of the sun is 400 times that of the moon, but it is also 400 times farther from the Earth than the moon. When looking at the sun and the moon from the Earth, they appear to be the same size in the sky. They are equal in apparent size. So when the moon passes in front of the sun, it totally blocks off the sun. The moon is precisely the right size and the right distance from the Earth to create a perfect total solar eclipse. Some people think that this is a stunning coincidence. I don't believe it's a coincidence at all. I firmly believe the fact that the sun and moon have the same apparent size in the sky and that their diameters are related by a biblically significant number, 400, was purposefully inscribed in the cosmos. Now let's look at their relative sizes. We'll zoom in on the sun by a factor of 20, while we zoom out on the moon by a factor of 20. This view will give us some sense of their relative sizes. There is the sun and the moon side by side. Of course, if you put them this close, the gravity of the sun would devour the moon and vaporize it almost instantly. Okay, we've done some work and covered some background facts and figures so that as we put together this eclipse diagram, we will have the insight to understand what is going on. Much of the background info was to help us keep a perspective of the sizes and dimensions in mind while we look at this diagram. Of course, the sizes and distances are not to scale. Even so, we will get some good insight from it. To get a solar eclipse, you have to have a sun. And of course, you're going to need an Earth. And as we reviewed, you will need the critically essential and improbable moon. Just for fun, we'll lay down a bit of background radiation. This is actually just to add a little bit of contrast to the diagram. And now we will add some ray tracing lines to help us see what's going on. So imagine you are on the Earth right at the point that the shadow cast by the moon lands on the Earth, right there. When you look up toward the sun, you won't be able to see it at all. The moon is covering or occulting the entire sun, and it would be somewhat dark outside. The dark shadow cast by the moon is called the umbra. Anything in the umbral region will be in total eclipse. There is always an umbra, there is always a dark shadow region behind the moon. Most of the time, the shadow cast by the moon will be in empty space. But when the moon passes between the Earth and the sun and through the pink box region, the eclipse zone, the umbra will fall on the Earth and you will get a total solar eclipse. The surface that intersects with the umbra will be a spot on the path of totality. We'll call this the spot of totality. Remember, the moon is moving through space in its orbit, and the Earth is also moving through space in its orbit, as well as rotating around its axis. These motions will cause the spot of totality to move across the surface of the Earth, scribing out the path of totality. A spectator positioned on the path of totality will experience a total solar eclipse. Let's add some additional ray tracing lines. These lines will help us identify the areas that are in partial shadow. The gray area is the partial shadow region and is called the penumbra. The penumbra always exists out in space too. Anytime anything goes into the penumbra, it will get partial shade from the sun provided by the moon. Someone viewing an eclipse from a location where the penumbra intersects the surface of the Earth will experience a partial solar eclipse. The closer you are to the path of totality, the higher percentage of occultation or higher eclipse obscuration you will experience, and the darker the shadow will be. These terms are just fancy words that mean what percentage of the sun the moon is blocking. If you have looked at an eclipse map, you will see lines with percentages attached to them. These lines are simply showing the paths that this percentage of occultation will follow. The width of totality of an eclipse can vary significantly. When the sun is closest to the Earth and the moon is its furthest away, we will get an annular eclipse. In an annular eclipse, there is no path of totality. The width of the path swept out by the antumbra is simply called the path width. When the ratios of size and distance from the Earth for both the sun and the moon are precisely equal, the width of totality is theoretically zero. However, since the sun and moon are not perfectly round and the surface of the Earth is not perfectly smooth, this is only theoretical. In this condition, the eclipse transitions between annular and total, and hence is a hybrid eclipse. For a total eclipse where the apparent size of the moon is only slightly larger than the sun, the minimum width of totality can be very narrow, close to zero. When the Earth is farthest from the sun and the moon is closest to the Earth, the width of totality can be over 165 miles at the middle of the Earth and significantly wider towards the poles. As a convention, in a total eclipse, the width of totality for a specific eclipse is generally given as its maximum width. For most total eclipses, the width of totality starts narrow and then widens to its maximum and then narrows again. If the maximum width of totality for a given eclipse isn't at least 39 miles, then it will likely be a hybrid eclipse because it will be annular when it starts out. The complex interplay between the elliptical orbits of the Moon and the Earth determines the path width. The width of totality of a total eclipse near the center of the globe ranges from 39 to 165 miles, slightly over a 4-to-1 ratio. There are 3 conditions necessary for a total solar eclipse to occur. The first 2 have to do with the alignment of the Sun, Moon, and Earth. These 3 celestial bodies need to be in a nearly perfect straight line. The third concerns the apparent size of the Sun and Moon as viewed from the Earth. The first requirement is that the Moon must be passing between the Earth and the Sun when viewed top-down from a heliocentric view. This happens 12 1/3 times per year. The second requirement is that the Moon must be within about 4,000 miles of Earth's orbital plane. This happens 26 3/4 times per year. The third requirement is that the Moon's orbit must be close enough to the Earth that the apparent size of the Moon is equal to or greater than that of the Sun's. These 3 conditions are met about once every 18 months. A solar eclipse occurs somewhere on the planet roughly every year and a half. There's an additional requirement if you want to view the eclipse. You must be in the geographic location where the umbra intersects with the surface of the Earth. You must be in the path of totality. If you wait for a total solar eclipse to come to you, you could be waiting for a while. Any given spot on the Earth lies in the path of a total solar eclipse about once every 400 years. If you hop in your Elon Musk spaceship and park it just beyond the Moon, slightly below the Earth's orbital plane, and with the Sun at your back, and you dial your DeLorean time setting to April 21st, 2017, this is what you will see. Of course, you wouldn't have that awesome music by Sean Williams playing, and you would have to sit there for half a day to see what that animation shows in half a minute. But it would be pretty epic just the same. We've covered the relationships between the Sun, Moon, and Earth, their sizes, distances, and their orbital paths. We've also reviewed the basic geometries and conditions necessary for an eclipse to occur. With this groundwork of understanding, we're going to shift gears and explore if the nature of an eclipse could meet the requirements to be a sign shown forth in the heavens above and the earth beneath. Let's take a look at the general as well as some specific characteristics of what a sign is. Once we complete this review, we should have an excellent foundation to evaluate and begin to answer the question, can an eclipse be a sign in the heavens? Signs, in a general sense, have several primary characteristics. They're communicative. Signs are meant to convey information, instructions, or messages. They're a medium of communication between the sender and the receiver. They're also symbolic. Signs often represent something else. They're symbolic in nature, standing for or representing a concept, idea, or entity. They have to be observable. Signs are perceptible in some way, whether visually, audibly, or through other senses. They are meant to be noticed and understood. By definition, they are intentional. Signs are usually created or used with a specific purpose or intention. They are not random or meaningless, but are designed to convey a specific message or serve a particular function. In a more specific content, such as miraculous signs in a religious context or signs used in scientific experiments, there are additional characteristics to consider. The first is relevance, then significance, uniqueness, rarity, authentication, improbability, and predictiveness. This is not an exhaustive list, and they overlap somewhat, but we can build a very good framework from these characteristics. We'll briefly discuss each of them. Relevance is a crucial characteristic of a sign. A sign must be relevant to its intended message or the context in which it's used. The information or symbolism it carries should be pertinent and meaningful to the situation. For example, in a religious context, a sign from a divine entity is often directly related to the message or prophecy it accompanies. It's not random, but rather explicitly chosen or designed to illustrate, confirm, or predict the spiritual truth being communicated. In a more everyday context, think about traffic signs. They are relevant to drivers and pedestrians who need to follow certain rules for safety. A stop sign is placed at intersections where vehicles need to halt. It wouldn't be relevant or useful in the middle of a highway. In a scientific experiment, a sign or signal is relevant if it's directly related to the hypothesis being tested. For instance, if scientists are testing a new drug, a decrease in symptoms in the test group compared to the control group would be a relevant sign of the drug's effectiveness. So, relevance ensures that a sign serves its purpose effectively in its specific context, making it a key characteristic of a useful and meaningful sign. Significance is a crucial aspect of signs. A sign is considered significant if it carries important information or has a meaningful impact on the situation at hand. The significance of a sign often lies in the importance of the message it conveys, or the effect it has on the understanding, behavior, or decisions of those who perceive it. For example, in a religious context, signs are often significant because they convey divine messages, demonstrate divine power, or confirm divine promises. In the Bible, when God gave Noah the rainbow as a sign, it was significant because it symbolized God's covenant never to destroy the earth by flood again. In a scientific context, a sign is significant if it provides crucial evidence supporting a hypothesis or theory. For instance, the presence of certain symptoms can be a significant sign of a specific disease. In a business context, a sign such as a company logo or trademark is significant because it represents the company's brand and identity. It can influence consumer perceptions and decisions. In a societal context, signs like traffic signals are significant because they regulate traffic and ensure safety. Ignoring these signs can lead to accidents. So the significance of a sign ensures that it serves a meaningful purpose and has a substantial impact in its specific context. It's not just about being noticeable, but about conveying something of importance. Uniqueness can be an important aspect of certain types of signs. A sign may be considered unique if it is distinct, rare, or extraordinary in some way. This characteristic is particularly relevant when the sign is meant to capture attention, signal a rare or significant event, or distinguish something from its surroundings or from similar entities. For example, in a religious context, signs and miracles are often unique events that seem to defy natural laws, making them stand out as divine interventions. The parting of the Red Sea in the biblical Exodus story, or Jesus turning water into wine in the New Testament, are examples of unique signs that demonstrated divine power and authority. In a business context, a unique sign or logo can help a company distinguish itself from its competitors. This uniqueness can make the sign more memorable and can contribute to the company's brand identity. In scientific research, a unique sign could be a rare or unexpected result that indicates a significant finding or breakthrough. For example, the observation of a rare astronomical event could be a sign of a new scientific discovery. However, it's important to note that not all signs need to be unique. Many signs are common or universal, such as traffic signs or common symbols, and their effectiveness relies on their widespread recognition rather than their uniqueness. The need for a sign to be unique depends on its purpose and context. Rarity can be an important characteristic for certain types of signs. A sign is considered rare if it doesn't occur frequently or is not commonly seen. The rarity of a sign can make it more noticeable and impactful as it stands out from the norm. For example, in a religious context, signs are often rare, extraordinary events or miracles. Their rarity underscores their significance and the divine power behind them. In the Bible, the resurrection of Jesus Christ is a rare sign of his divine nature and the fulfillment of his prophecy. In a scientific context, a rare sign could be an unusual result or observation that suggests a significant discovery or breakthrough. For example, the observation of a rare celestial event, like a supernova, can provide unique insights into the workings of the universe. In a business context, a rare sign could be a unique selling proposition or a distinctive feature of a product or service that sets it apart from competitors. However, it's important to note that not all signs need to be rare. Many signs are common, and their effectiveness relies on their widespread recognition rather than their rarity. Traffic signs, for instance, are common and their messages are universally understood. The need for a sign to be rare depends on its purpose and its context. Authentication is an important aspect for certain types of signs. A sign can serve as an authenticator when it verifies, validates, or confirms the truth or authenticity of a message, event, or identity. This characteristic is particularly relevant when the sign is used to establish credibility, confirm a prophecy or promise, or verify the identity or authority of a person or entity. For example, in a religious context, signs and miracles often serve to authenticate a prophet's message or divine mission. In the Bible, the miracles performed by Jesus, such as healing the sick and raising the dead, authenticated his identity as the Son of God and his message as divine truth. In a legal or official context, a signature or seal can serve as an authenticating sign that verifies the identity of the signer and the authenticity of the document. For instance, a notary public uses a unique seal to authenticate legal documents. In a digital context, digital signatures, certificates, and other forms of encryption can serve as authenticating signs that verify the identity of a sender and the integrity of the transmitted data. In a scientific context, an authenticating sign could be a unique result or observation that confirms a hypothesis or theory. For example, the observation of a specific wavelength of light in a physics experiment can authenticate a theoretical prediction. So the characteristic of authentication ensures that a sign serves as a reliable indicator of truth, authenticity, or authority in its specific context. Improbability can be an important characteristic for certain types of signs. A sign is considered improbable if it is unlikely to occur by chance or under normal circumstances. The improbability of a sign can make it stand out and draw attention, and it can also add to its perceived significance or importance. For example, in a religious context, signs and miracles are often improbable events that defy ordinary expectations. Their improbability underscores their divine origin and the power of the deity involved. In the book of Judges, Gideon asked God for a sign to confirm that he would indeed save Israel by his hand as God had promised. The sign involved a piece of fleece, wet with dew when the ground around it was dry one day, and dry when the ground around it was wet the next day. In a scientific context, an improbable sign could be an unexpected result or observation that suggests a significant discovery or breakthrough. For example, the detection of a rare particle in a physics experiment could be an improbable sign of a new scientific phenomena. In a statistical context, an improbable result, one that is statistically significant, can serve as a sign that a particular effect or difference is not due to chance. For example, in a clinical trial, if a new drug shows significantly better results than a placebo, this is an improbable outcome under the assumption that the drug has no effect and can be taken as a sign that the drug is effective. However, it's important to note that not all signs need to be improbable. Many signs are common or expected, and their effectiveness relies on their clarity, relevance, and recognizability rather than their improbability. The need for a sign to be improbable depends on its purpose and context. Predictiveness is an important aspect of many types of signs. A sign can be predictive, meaning it forecasts or indicates something that will happen in the future. In a religious context, signs often serve as an indication of future events, blessings for obedience and cursings for disobedience. In the book of Isaiah, chapter 20, the prophet is commanded to go barefoot and naked for 3 years as a sign that the Egyptians will be led away naked and barefoot by the king of Assyria. In meteorology, certain cloud formations are predictive signs of upcoming weather conditions. Dark, towering clouds often predict a thunderstorm, providing a crucial warning for people that seek shelter. Similarly, in finance, specific economic indicators can serve as predictive signs of future market trends, helping investors make informed decisions. The characteristic of predictiveness allows the sign to provide insights or warnings about future events or conditions, which are crucial for anticipation and preparation. It has been said that the 3 most important factors in determining a retail business's success are location, location, and location. In a like manner, the 3 distinguishing factors between different eclipses are location, location, and location. The first location is on the Earth. This is the geographic region of the surface of the Earth that intersects with the umbra. This has 2 different but related aspects. The first aspect is the path of totality, or more specifically, the center line of the path of totality. The second aspect is the width of the path of totality, or the width of totality. Here is an eclipse map showing all of the annular, hybrid, and total eclipses between the years 2011 and 2060. Notice that there are a lot of eclipses over this 50-year period. Also notice that the paths, when viewed from west to east, are arcs that generally rise and head northward or fall and head southward. This is because as the moon crosses through the Earth's orbital plane, it is either ascending or descending through it. Another thing to notice on this map is that the path widths vary significantly. Some are quite narrow. For instance, notice the April 30th, 2041 eclipse across Africa, right here. Some paths are very wide. Check out the August 23rd, 2044 eclipse starting in North America, right here. And of course, the rest are somewhere in between. So the second location is the location in the heavens. Depending on the eclipse date, the sun will be at a specific location in the ecliptic. The sun will be in a specific constellation and will be closest to a particular star or group of stars. There may also be planets in a specific configuration. As soon as someone says constellation, many people immediately think astrology. Astrology is a contraction of astropsychology, star psychology, meaning psychology or personality based on the stars. It is a form of divination and fortune-telling akin to sorcery. Although popular, there is no convincing scientific evidence for the validity of astrology. So we are definitely not talking about astrology. We are talking about astronomy. The word astronomy literally means the laws and names of stars. The Greek word aster, onoma, and nomos are translated as star, name, and law, respectively. Astronomy is the science of celestial bodies, their creation, magnitudes, motions, and composition. And although it is considered a modern science, numerous ancient civilizations have demonstrated a significant understanding of celestial bodies. Enoch, Abraham, and Moses were 3 examples of ancient prophets who had knowledge of countless creations revealed to them by deity. The third location is the location in time. The primary aspect of this location is the date the eclipse occurs. There are other numerous divisions in time, but they are usually relative to a specific geographic location. For instance, the spot of totality might move from being in the ocean to being on the land at a specific time. You might say the eclipse made landfall at such and such a time. There will be a time and location for maximum eclipse duration. Also, there will be times for first through fourth contacts for a given location as an eclipse moves through its phases. By having a moon of an unusually large size that produces an array of protective and life-promoting benefits and an energy-providing Goldilocks-sized sun, not too big so it has a longer lifespan, and not too small so it remains stable, we won the cosmic lottery. Not only that, with their ratios of size to distance from the Earth being roughly equal, so their apparent size in the sky is the same, we hit the eclipse jackpot. We are so fortunate, so lucky in fact, that it is more than reasonable to consider that actually something intentional is going on. So if we consider a specific eclipse and its unique aspects of location on the Earth, location in the heavens, and location in time, and evaluate each of these aspects with regards to the general and specific characteristics of signs, we can get an idea if this particular eclipse carries some sort of significance. Early in August of 2017, I began a journey without even realizing it, a journey that would fundamentally change me. It had been 45 years since I had contemplated viewing an eclipse, but finally, one was less than a 5-hour drive from my home. I wanted to experience it. I was going to watch the Great American Eclipse. I called my brother and my buddy Sky to enlist them in this adventure. We hitched up the fifth wheel and drove up to Lander, Wyoming. We didn't know what we were doing as far as eclipse photography was concerned, but we knew we wanted to be smack dab in the middle of the path of totality. We drove around for 2 days scouting a location. The center line of totality passed right through the middle of Dinwoody Lake, so we went to the lake to check it out. On our way there, we came upon a movie set and a film crew shooting a Western. We hung out for a bit to take in the action, but it was only a short time until their security persuaded us to resume our site scouting efforts. Since we were in the area, we visited Sacagawea Cemetery on the Wind River Indian Reservation at Fort Washakie. We finally settled on a location along the Wind River called Jenkins Draw. The site was on reservation land. Getting permission was easy as long as we weren't planning on hunting or fishing. This is an aerial view from Google Maps. You can see the bridge crossing the river at Jenkins Draw. I had a little fun with it, referring to it as Jenkins Drawbridge. There's my buddy Sky setting up his 360 camera. This is my brother Barry setting up his camera. Back in the day, we hiked and did a lot of rock climbing. He saved my life one time when we got caught in an avalanche while we were ice climbing. But today, no fishing, no hiking, no rock climbing, no ice climbing. We were going to experience our first total eclipse. You can see Sky's 360 camera in the background right there. And you can also see my camera that I set up for a time lapse right there. Here is the time lapse. There were a few people that launched to see the eclipse from the river and to do a little fishing. Working our way to totality, you can see it's starting to get darker. With the camera exposure fixed, it becomes very obvious how much the light is changing. With your naked eye, the change in light doesn't seem nearly as dramatic. It sort of sneaks up on you. Okay, so that was it. That was the time lapse. And here's yours truly donning my hyper-stylish but very safe eclipse spectacles. I'm standing in front of a long-lost friend, my black Ford F-350, who gave up the ghost just a year and a half later in a freeway hydroplaning experiment that went terribly wrong. Like I said, we didn't know what we were doing, and we didn't have the right photography gear to get really good eclipse photographs, but we did get a couple of shots that I consider personal treasures. This one is the midpoint of the eclipse. This is a time-lapse composite I put together of the diamond ring effect. I'm particularly fond of the lens flare on the Sony 28 through 70 G Master zoom lens. It's a beautiful lens, but it's not nearly long enough for good eclipse pics. So that's it. Those are the shots I got. I love them not because they're very good, but because they're reminders of an incredible experience. If you haven't experienced a total eclipse, I would highly recommend it. In fact, I'll even go further. I'll steal the words from self-proclaimed umbraphile David Barron. Before you die, you owe it to yourself to experience a total solar eclipse. That line's from a TED Talk that you really ought to check out. I've left a link in the description. Although we were the only ones at Jenkins Straw during totality, a gazillion other people across America were also taking in this awe-inspiring spectacle. Among these was a guy at an eclipse party in Salem, South Carolina. I say a guy because I read his account on a blog post, but I haven't been able to find it again. He described a DJ on the radio saying, "The eclipse is over Salem, Oregon." He thought, Salem, Oregon? I'm in Salem, South Carolina. I wonder if there are any other Salems that the eclipse crosses. He later pulled out Google Maps and found there were. In fact, there were 7 of them. Salem, Idaho, Salem, Nebraska, Salem, Missouri, Salem, Kentucky. And not on Google Maps, but he found an abandoned city, Salem, Wyoming. Little did I know that this would plant the seeds for a 2-year journey, mostly through books and history, but also several thousand miles of windshield time. When I first heard of the 7 Salems, I thought, that's kind of cool. But at the time, I was mostly uninterested and somewhat dismissive of it. That was until the March 18th, 2020 earthquake that hit Salt Lake City. I then dug into it and I found some stuff that was mind-boggling. By then, there were lots of blog posts that were full of interesting facts and speculations about the eclipse, but none that I had found mentioned what I'm about to show you. The thought occurred to me that no one had mentioned the most important Salem in the Western Hemisphere, the new Jerusalem. So I got out the eclipse maps and I took a look. At 15 seconds after 1:09 p.m. Central Daylight Time, the spot of totality was right here. If we zoom in, we can see Kansas City towards the bottom. There's Kansas City. At the northern perimeter, we can see the spot of totality just catches the site of Adam-on-Diamond. According to modern revelation, Adam-on-Diamond is the place where Adam gathered all his righteous posterity, blessed them, and predicted whatsoever should befall them unto the latest generation. It is also a place where, as part of the second coming, Adam will come to visit his people, where the Ancient of Days shall sit, as spoken of in the 7th chapter of Daniel. At the southern perimeter, we can see the spot of totality covers the temple lot in Independence, Missouri. According to Latter-day Prophecy, the temple lot is where the temple, the apex of the hierocentric city, the New Jerusalem, will be built. When we add the outline of the city of Independence, the picture becomes even more mind-boggling and filled with significance. Here's a closer view. Independence, Missouri fits almost perfectly within the spot of totality. Independence was the place where religious settlers early in the 1830s went to build Zion, the New Jerusalem. They were run off their land they had purchased, by Missouri mobs. This persecution included murder, rape, and theft. Persecution so vexing, it ultimately included an extermination order from the governor of the state of Missouri, Lilburn Boggs, a name that will live in infamy. This extermination order stood for 138 years and was finally rescinded on June 25, 1976, just 9 days before the United States of America, the country that has been the bastion of religious freedom to the world, celebrated its 200th anniversary of proclaiming what? Independence, of proclaiming independence. This independence was won with the blood of patriots in a war that started a year previous to the Declaration of Independence at the battles of Lexington and Concord and would continue for another 7 years, costing the lives of tens of thousands. Even though prevailing circumstances wouldn't allow these early saints to live on the land they had purchased, they were instructed not to sell it. that the lands purchased with their monies to establish Zion would eventually be redeemed. This eclipse precisely covers these two areas, both replete with ancient and modern history as well as prophetic significance. At that moment in time, 15 seconds past 1:09 p.m. Central Daylight Time, August 21st, 2017, the width of totality of 70.3 miles precisely captured these two spots. Any wider and it wouldn't have been precise. Any narrower and it wouldn't have captured them. The center line of this eclipse was in exactly the right path. Any further north, it wouldn't have captured Independence. Any farther south, it wouldn't have captured Adam-on-Diamond. As the popular child story puts it, this eclipse was just right. But just how frequent might an eclipse do this? If it happened every 10 or 50 years or so, it wouldn't be rare enough to rise to the level of being a sign. A sign of this type would have to be rare, extremely rare. This is an eclipse map from the NASA Eclipse website. It's a map of the eclipses between 2000 and 2020. There are 250 of these maps that show 5 millennia of eclipses for the past 4,000 and the next 1,000 years. 3,173 total eclipses to be exact. There's also an eclipse calculator that calculates local eclipse circumstances for any geographic location on the Earth. By using the maps in the calculator, I found that there are 12 total eclipses that capture the points of Spring Hill in Adam-on-Diamond and the Temple Lot in Independence between the years of 1500 BC to 3000 AD. Out of those 12 total eclipses, only one has a width of totality close to the eclipse of 2017. But it crosses the points at such an angle that both points aren't in totality at the same time. After several days of research, I can confidently say that in this 4,500-year period, there is no other eclipse that comes close to our Goldilocks eclipse. The August 21st, 2017 eclipse, as it relates to these two locations, is extremely rare. One of the things about this eclipse that seemed to create some buzz was the fact that it crossed land exclusively in the United States. I thought I would go back and find the last total eclipse that did the same. I had to go back almost 800 years. The last total eclipse to cross only the land now known as America occurred on June 13th, 1257, and that's this eclipse right here. To add a pinch of historical perspective, this eclipse was 3 decades after Genghis Khan had killed nearly 40 million people, or 10% of the world's population, and pushed the peoples of Europe west. It was also about a century before the plague of the Black Death. So I hope these details give a little perspective on how rare the 2017 total eclipse was. In Douglas Adams' 1979 sci-fi novel, The Hitchhiker's Guide to the Galaxy, the supercomputer named Deep Thought reveals that the answer to the great question of life, the universe, and everything is 42. However, this answer wasn't very helpful, so Deep Thought decided it had to build a new and better version of itself to figure out the right question to ask. Similarly, everyone wants to know the answer to the question, when is the second coming? If we could put this question into the supercomputer, the answer wouldn't be all that helpful unless we first got an answer to the question, what is the second coming? By using just 3 references, I'll answer that question. The first reference is from Joseph Smith Matthew. In chapter 1, verse 26, we read, "For as the light of the morning cometh out of the east, and shineth even unto the west, and covereth the whole earth, so shall also the coming of the Son of Man be." Think about how the dawn breaks. It doesn't go from pitch black to noonday instantly. There's a gradual increase in light starting in the eastern horizon. It gets brighter and brighter. Then the edge of the sun peaks over the horizon. Then more and more the sun appears until the entire sun is visible. It's a gradual process that takes place over a few hours. Now let's go back and read from Joseph Smith Matthew again. "For as the light of the morning cometh out of the east, and shineth even unto the west, and covereth the whole earth, so shall also the coming of the Son of Man be. The next reference is from the talk, 5 Marks of Divinity of Jesus Christ. It was given by Ezra Taft Benson at the University of Utah Special Events Center on December 9th, 1979. The final reference is from The Millennial Messiah by Bruce R. McConkie. The second coming is comprised of 4 groups of increasingly public appearances of Jesus Christ. Quoting President Benson, his first appearance will be to the righteous saints who have gathered to the New Jerusalem. In this place of refuge, they will be safe from the wrath of the Lord, which will be poured out without measure on all nations. The second appearance of the Lord will be to the Jews. The Savior, their Messiah, will appear and set his feet on the Mount of Olives, and it shall cleave in twain, and the earth shall tremble and reel to and fro. The third appearance of Christ will be to the rest of the world. And the Lord shall be red in his apparel, and his garments like him that treadeth in the wine vat. This is the visit that marks the destruction of the wicked and the dramatic changes to the earth which transform it into its millennial state. In The Millennial Messiah on page 578, Bruce R. McConkie names these 3 appearances and then says, before these, he will come in private to his prophet and to the apostles then living, those who have held keys and powers and authorities in all ages, from Adam to the present, will also be present. Okay, so let's go back to the original question. Was the 2017 eclipse a sign in the heavens? Let's do a quick review of the characteristics of signs. The general characteristics: communicative, symbolic, observable, and intentional. The specific characteristics: relevance, significance, uniqueness, rarity, authentication, improbability, and predictiveness. Keeping these in mind, let's review the attributes of the 2017 eclipse. The path of totality crosses 7 cities named Salem, and at one point is just wide enough to cover 2 specific locations, both with great historical and prophetic significance. So great, in fact, they are the sites of 2 of the most important events to be, not only in the entire history of the world, but in the creation of the solar system and even the universe as it relates to man on this earth. The width of totality was just right. The path of totality was just right. In considering the 3 distinguishing factors between different eclipses: location on the earth, location in the heavens, and location in time, I submit that for the first of these factors, we can put a check in the box. As far as the location of totality on the earth, the total eclipse of August 21st, 2017, the Great American Eclipse, meets the requirements of being a sign in the heavens. All right, that's it for this episode. Keep watching the skies and be sure to watch the next episode of Sign of the Eclipse: the lion, the sickles, the kings of the harvest. Agree with us or not, we'll keep bringing you stuff that will keep you thinking.